In these problems, we are finding antiderivatives. You know how to take derivatives. What's an antiderivative? Well, it's a lot like what it sounds like. It's kind of the opposite of a derivative. Let's start by just thinking about something we know how to take the derivative of. X squared, we're going to apply the power rule, and the power rule says you multiply out front by the power, so that becomes 2x, and you decrease that by 1, so this becomes 2x to the first power instead of to the second power, and that's the derivative. When we take the antiderivative, we do that all in reverse. So the first thing we're going to do is actually raise this power from 1 to 2, and then we multiply it not by the power, but by the reciprocal of the power. So 1/2 times 2 is 1, and we get back to x squared, which is where we started. However, we can't really say that x squared is the antiderivative of 2x. Um, and the reason is that we could get a derivative of 2x from x squared, or x squared plus 1, or x squared minus 17, or x squared plus 1,000, because all of those constants just go to 0 when you take the derivative. So when we take the antiderivative of something, so we add in a plus c, because this could have been just x squared, but it could have also been any one of these other things with a constant. So the big C, capital C, is our arbitrary constant that we have to add in when we take an antiderivative. So let's see how this works here. We have f of t equals -3 times t, and t is to the first power. So the first thing I'm going to do is raise that power by 1, and then multiply out front by the reciprocal. So 1/2 times -3 is -3/2, and then we've got t squared now plus our arbitrary constant. And that is the antiderivative. You'll notice when you take the derivative of something, the power always goes down with these algebraic expressions. When you take the antiderivative, the power goes up. Let's try another one. This looks a little more complicated. I think I'm going to rewrite this as 2/3 times t to the -1/3. That's the cube root of t down there. It's on the bottom of the fraction, so that gives us the -1/3 power. This is going to be a little easier to apply our sort of reverse power rule to. So the first thing I'm going to do is raise this power by 1. So -1/3 plus 3/3 is going to be t to the 2/3. I've still got my 2/3 out here. And now I'm going to multiply by the reciprocal, which is 3/2. And 2/3 times 3/2, well, that's 1. Everything cancels there. So we just get t to the 2/3 power plus our arbitrary constant, big C. All right, let's try one more. This one might look confusing at first. -4, what do we do here? There isn't even a variable. Well, we're told this is a function of z, so our variable is z, and we can think of this as -4 times z to the 0 power, because anything to the 0 power is 1. So that's how to think about that. And now I can apply this reverse power rule here to get the antiderivative. I'm going to increase the power to 1. That gives me z to the first power. And then I would multiply by the reciprocal of 1. Well, that's just 1, so it's going to be -4z plus our constant. And you can see, if you want to check your work on these, just take the derivative. What's the derivative of -4z? Well, it's -4. So you reduce this power by 1, and after multiplying by 1 out front, you've got just -4. So that is how to find an antiderivative.